Hi there. Next, what should we jump into? We looked at permutations and combinations. We looked at propositional logic. Now let's look at some set theory. In fact, for that equivalence class partitioning and many more techniques, the whole thinking can be based on a lot of good set theory that we know. Simple set theory, collection of things which have a common property. Months in a year, sports kit for badminton, common property. Common properties, it is meant for badminton. Months with 31 days, for example. And there are various representations that you can have in terms of listing elements, giving a decision rule, or probably another way of decision rule where we are talking about percentage of commission. This starts putting together some of these elements which make sense and all of them have a common property. This is what we'll need many times. The whole thinking is around that common property. And set theory is so close to the way human beings think. It is always surprising how set theory can be easily understood. In fact, school children can understand set theory pretty easily if they are told in a particular manner. So this is something that resonates with the way we think. The other part is pictorial representation. Pictures that can say 1,000 words. So this is pictures for sets. And this is like a Venn diagram of a 30-day month. So this is the set. This is the universal set. So this is U. This is our set A. This is all 30-day months in a year. And in fact, Venn diagrams further would give rise to intersection of sets and union and other operations that we need to do. But it's a pictorial view. So what are the set operations that can be done? Union, intersection, complement, relative complement, and then symmetric difference that we could find out. It would be important for each one of you to go ahead and look at even the Venn diagrams corresponding to these set operations. There's a lot of value in it. Visually, they are not only more appealing, but also easily understood. In fact, one of the techniques, which is equivalence class partitioning, can be very well done using set and set theory and even set operations. The other piece is about representing an unordered pair and an ordered pair. Do you remember somewhere where we looked at ordered pair and unordered pair? Something to do with permutations and combinations? Yes, in set operations as well, we can do that. Set relations, we have subsets. One set could be a subset of another set or a superset of another set. I would strongly urge you to look at set theory and set theory where we are looking at subsets, where a subset where one set is having all its element present in the superset. Equal sets, for example. Those are all set relations which are useful for us when we get into some amount of test case design. In fact, test input design or domain design. Set partition. One of the things that comes to my mind when you look at how you wish to partition the set is that, say, if this is a set and I wish to partition the set like a pizza. Each part is unique. Each part, when put together, forms the whole set. It divides the whole in parts. With each of them as a property, so if I'm looking at a typical half and half with half having certain toppings and other half having another set of toppings on a pizza, then you know that pizza half has a certain property, the other half has a certain property. So this becomes pretty useful when we are looking at creating those subsets, particularly based on certain values. One of the pieces that I know of is that if this is the population, the first division could be gender-based, male and female. The next could be based on age. Further could be again based on age. So I could have children, adults, senior citizens. Children, adults, senior citizens. So you can see how these partitions would mean. Someone who's a child and a male or a female is unique in terms of its own set. This is how you could start off and start using the set theory from a testing perspective. So that's what we had. Again, the base for set theory. You would see that this is how we are treating all of our math pretty informally from a high level perspective. And the expectation is that you get motivated, you look at it. I hope you're inspired enough to take the high level math and take it to the techniques that we need throughout this entire semester of yours. Thank you.